Just like we can add and subtract polynomials, we can add and subtract radicals. So in order for us to be able to add and subtract radicals, what has to happen is what's underneath the radical has to be the same. So I could not combine 5 square root of 4 and 5 square root of 3 because square root of 4 is different than square root of 3. Okay. I also could not combine 8x square root of 2 minus 3x square root of 2x because 1 is 2 and 1 is 2x. So the square root of 2 is different than the square root of 2x. And lastly, I could not combine this last one, x cubed square root of 10 and 7x squared square root of 10, because it's x cubed and x squared. So x cubed is different than x squared. So if I want to combine some like terms, it says I'm supposed to write a like term to match each one. Well, 5 square root of 4 would be a like term with something like 7 square root of 4. 8x square root of 2 would be a like term with something like 3x square root of 2. And x cubed square root of 10 would be something similar with 3x cubed square root of 10. What has to be true is they have to have the same variables, exponents, and square roots. Okay, so we can only add or subtract radical expressions if and only if they have the same square roots, same variables, and same exponents. So if you look at this example down here, we have x times the square root of 3 plus square root of 3x plus 4x square root of 3 plus 2 square root of 3x. So the first thing I'm going to look at is what's underneath the square root. So I have two of them that have a square root of 3. And I also have to make sure they both have an x with them in front, and they do. So that means I can combine x square root of 3 with 4x square root of 3. And then I have the plus 3 square root of 3x and the plus 2 square root of 3x. So again, those are also like terms. So x square root of 3 plus 4x square root of 3, that's 1 plus 4 is 5x square root of 3. And then I have 1 square root of 3x plus 2 square root of 3x, and that is 3 square root of 3x. So that would be my final answer. For the next one, I have 4 square root of 5 minus 3 square root of 2x minus 6 square root of 5 minus the square root of 2x. So I have both of these that have the square root of 5, which would be 4 square root of 5, and minus 6 square root of 5. They're like terms. And then my minus 3 square root of 2x and my minus 1 square root of 2x are also considered like terms. So 4 minus 6 would be negative 2 square root of 5. Negative 3 minus 1 is negative 4 square root of 2x. So that would be my final answer. Now the problem is that sometimes we look at the problem, like both of these two, and we think, oh, there's nothing I can do. So what we're going to do first is we're actually going to prime factor, and simplify these square roots. So I'm going to start with 20, and I'm going to list out the prime factors of 20. Well, 20 is 5 times 4, and 4 is 2 times 2. So the square root of 20 is really 5 times 2 times 2. And I'm looking for pairs. I have a pair of 2's, so I can bring that out and leave us 5 on the inside. And then I'm going to do the same thing for 45. So I have 45, and I'm going to prime factor it. 45, I can say that's 5 times 9. 9 is 3 times 3. So 45 is really 5 times 3 times 3. And I'm looking for pairs of numbers. So I'm going to bring a 3 outside and leave the square root of 5 on the inside. And they are still added. So now these are like terms because they both have just square root of 5. So 2 square root of 5 plus 3 square root of 5 is 5 square root of 5. And that would be my final answer. So right now, looking at the next problem, I can't combine anything together because, yes, these two at the end both have x cubed, but one of them has a 4x cubed, so I can't combine them. So I've got to see if I can simplify. Well, I can't simplify x square root of x, but if I start with x cubed, that's x times x, and I have a pair of x's, so that becomes x square root of x. So right now I have x square root of x minus x square root of x. And then if I look at 4x cubed, well, 4, if I prime factor that, it'd be 2 times 2, and then 3 x's. And I'm looking for pairs. I have a pair of 2's and a pair of x's. So I can rewrite this as 2x square root of x. So plus 2x square root of x. If I put coefficients there, that's 1x square root of x minus 1x square root of x plus 2x square root of x. 1 minus 1 is 0, plus 2 is 2. So I end up with 2x square root of x as my final answer. So for number 1, I have to take the square root of 27 and simplify that. Well, 27 is 3 times 9, and 9 is 3 times 3. So the square root of 27 is really 3 times 3 times 3. Again, I'm looking for pairs. And I have a pair of 3, so I can rewrite this as 3 square root of 3. So I have 3 square root of 3 plus, I can't do anything with this 4 square root of 3 because square root of 3 is as small as it can go. I can't prime factor square root of 3, so plus 4 square root of 3. And I can add those together because they both have square root of 3 on the end, and 3 plus 4 gives me 7 square root of 3, that being my answer. Number 3, I have the square root of 128 minus 2 square root of 2. So I'm going to start with 128. I know it's even, so I'm going to divide it by 2, and I get 64, which I know is even, so I'm going to do 2 and 32, which 32 is even, that's 2 and 16. 16 is 2 and 8. 8 is 2 and 4, and 4 is 2 and 2. So that's 1, 2, 3, 4, 5, 6, 7 2's. So the square root of 128 is really 1, 2, 3, 4, 5, 6, 7 2's. And I'm looking for pairs. Well, I have 1, 2, 3 pairs of 2's. So that's going to become on the outside 2 times 2 times 2, and then square root of 2 on the inside. 2 times 2 times 2 is 8 square root of 2, and then I have to bring down my minus 2 square root of 2. Well, these are like terms, so I can go ahead and subtract 8 minus 2. 8 minus 2 is 6 square root of 2, and that would be my final answer. For number 5, I'm going to have to prime factor 75 and 48. So 75, I know that that is 5 and 15. 15 is 5 and 3. So square root of 75 becomes 5 times 5 times 3. And I'm looking for pairs. I have a pair of 5s, so it's 5 square root of 3. So right now I have 5 square root of 3 minus, okay, this 2 square root of 3. I can't do anything with square root of 3, so it's going to stay 2 square root of 3. 48, however, I can prime factor. 48, I know I can divide that. That's 6 and 8. 6 is 2 and 3. 8 is 2 and 4. And 4 is 2 and 2. So I'm looking at all of my end numbers. And I always write them in order. It just kind of helps out. So I have 1, 2, 3, 4 2's and a 3. And I'm looking for pairs. I have a pair of 2's and I have another pair of 2's. So that means on the outside I'm going to have 2 times 2, and on the inside just 3. 2 times 2 is 4, so I'm left with square root of 3. So plus 4 square root of 3. And then I have to look to see if I can combine these. Well, these all just have square root of 3, so I can. So I just have to do 5 minus 2, which is 3, plus 4 is 7 square root of 3. So I have to start for number 7. I have the square root of 24 minus the square root of 54 minus the square root of 150. So I'm going to start with 24, and I'm going to prime factor that. Well, 24 I know is divisible by 3 and 8. And 8 is 2 and 4, and 4 is 2 and 2. So the square root of 24 is 2 times 2 times 2 times 3. I'm looking for pairs of numbers. I have a pair of 2's, so that gives me 2 on the outside, and then I have 2 times 3 on the inside. Well, 2 times 3 is 6. So I have 2 square root of 6 for the first part. Then I start with 54. Well, I know 54 is divisible by, and I don't really know the start. I know it's even, so I know it's divisible by 2. It's actually 2 and 27. 27 is divisible by 3 and 9, and 9 is 3 and 3. So the square root of 54 is 2 times 3 times 3 times 3. And I have a pair of 3's, so it becomes 3 on the outside, and on the inside, 2 times 3, which is 6. So minus 3 square root of 6. And then I have the square root of 150. So I'm going to start with 150. Well, I know that's divisible by 5 or 10. You can really kind of do a bunch of different things here. I'm going to go with 5. It's 5 and 30. 30 is 5 and 6, and 6 is 2 and 3. So the square root of 150 is the square root of 5 times 5 times 2 times 3. I have a pair of 5's, so that becomes 5 on the outside and 2 times 3 on the inside, which is 6. So minus, because there's a minus sign there, 5 square root of 6. Well, all of these are like terms because they're all just square root of 6. So I just need to figure out what's 2 minus 3 minus 5. Well, 2 minus 3 is negative 1, minus 5 is negative 6 square root of 6, and that would be my final answer. All right, number 9 is the last one. So I have the square root of x cubed minus 5x cubed, square root of x cubed, plus 2x square root of x. So starting off with x cubed, well, x cubed is really just x times x times x, and there's a pair of x's, so I get an x on the outside and an x on the inside. So I have x square root of x minus, well, if this was also just the square root of x cubed, nothing else with it, it's also going to be x square root of x. I still have to have that 5 there because it was there to begin with, so I'm just going to leave it in front. Plus 2x square root of x. Well, all of these have x and square root of x in there. This first one is a 1, so I can combine them all. 1 minus 5 is negative 4, plus 2 is negative 2x square root of x. And that would be my final answer.